Today I'm going to talk about the introduction of vectors. Imagine if we're on a boat sailing across the ocean. The velocity from the engine heading to the north, but we can't go straight because there is a wind from the east that affects us. Actually, the boat will go northwest at a certain magnitude. To calculate the resultant velocity of the boat, we introduce the vectors. So, what is a vector? A vector is a mathematical quantity. Here we emphasize the magnitude and the direction. That means if two vectors have the same magnitude and direction, we will say they represent the same mathematical quantities. To do the addition for two vectors, we will apply the parallelogram law. Here we have vector A and vector B. Their summation will be the direction and magnitude, showed as in the red vector. Now, let's see the first example together. A small airplane is flying due north at 150 km per hour. It encounters a wind of 80 km per hour from the east. So what is the resultant ground velocity of the airplane? We have vector u and vector v, and we know the resultant velocity is their summation. By using the parallelogram law and triangle addition rules, we have their magnitude of resultant velocity as 170 km per hour. To represent a vector, we will need the magnitude and direction. To calculate the angle theta, we will apply the cosine law. Now we have the theta equals to 28.1 degree. Then we say the resultant ground velocity of the airplane is 170 km per hour in the direction of 28.1 degree northwest. We've learned that we can use the parallelogram law to do the vectors addition. Actually, we can translate the tail of vector to the head of the vector. Then the resultant is the vector from the tail of the beginning vector to the head of the vector, the last vector. Another mathematical operation of vector is subtraction. To calculate the difference of two vectors, we can add the opposite vector by using the triangle law of addition. Now let's see the second example together. Here we do the mathematical option for multiple vectors. First question, vector PQ plus vector QR plus vector RT. Remember, the resultant vector is from the tail of the first vector to the head of the last vector. So the answer is a vector PT. Second question, we can first rewrite the vector TR as its opposite vector RT. Now it's easy to get the resultant. Start from vector PQ and then vector QR and vector RT. The answer is vector PR. The last one, we first take off the bracket and then the expression is rewritten. Then we substitute the subtraction with an opposite vector and organize their order. Now we will calculate the resultant for vector ST plus vector TP plus vector PR, and the answer will be the vector SR.